Good morning, everyone. This is actually the first video that I'm recording after the May holidays. And as you might have watched the last video, I said that there was 7.1 part 1, but that was just 7.1. I lied, sorry. In this video I'm going to talk about 7.2, not part 1 because it's just 7.2, this I'm not going to lie to you again. And we're going to talk about special triangles. So, what are special triangles? They're not glowing or anything, it's just basically a triangle with some special properties. And there are 3 of them that you have to know. The first one that we're going to look at will be an isosceles triangle. After that, we're going to look at the equilateral triangle. And the last one is the right-angled triangle. But first we're going to look at the isosceles triangle. And what's special about an isosceles triangle? It's basically a triangle in which 2 of the lines are equal. Okay, so first let's draw one. And I want you to draw this in your notebook as well. So let's draw these ones over here. I have a protected triangle, of course not. So this also usually works pretty well, if you know how. Drawing straight lines with a pair of compasses. And this is A, B, C. Well, obviously the 2 lines which are equal are AC and BC. Okay, so this is an isosceles triangle. That's not the only thing, because we're going to use the fact that if there are 2 lines which have an equal length, then there are also 2 angles which are equal, which are these 2. In the textbook they're also using several terms, so you need to know those as well. And the first of them is, I'm going to draw a little man over here. These things, these 2 lines that are equal, are called the legs. So there are 2 legs, and both of these legs are standing on top of the base. So this line over here is called the base. Well, luckily for us, there are 2 angles which are connected to the base. The 2 angles that are connected to the base are equal, and those are called the base angles. Okay, so does this one have a name as well? Yes. This one is called the vertex angle. Because point C over here, this is called the vertex. So basically, this could be useful. For example, if you know that this angle is 80 degrees, then this angle also has to be 80 degrees. Sometimes it helps you with one extra step to calculate angles in a triangle. Hopefully it's enough about the isosceles triangle. The second one, we have this one. I'm going to look at the equilateral triangles. And I'm going to draw one as well. How am I going to do that, let's draw like this. It's actually harder without a protected triangle, but bear with me. This is about right. Still not sure why I didn't go to the other classroom just to get the protected triangle. But sometimes I'm being lazy as well. DEF. What's special about this one, maybe if you look at it you already know. In this case are two lines that are equal. In this case there are three equal lines. And maybe it will come as a surprise you, maybe it won't. In this case we have two equal lines and two equal angles. In this case there are three equal lines and also three equal angles. So angle D, E and F are all the same. And you will see that all of these angles are exactly 60 degrees. In the next paragraph you'll see that this is not a coincidence. This is true for every single equilateral triangle. Just to make sure, DE is the same as EF, which was the same as DF. Okay. You could have written down something like this over here as well. Then you would have had AC is equal to BC. But you don't know how big these angles are. Those could be different. Those could be 80, but they could also be 20, for example. But what you do know is that angle A is equal to angle B. So those are the two difficult ones. And then there's one more triangle left, which is the right-angled triangle. A right-angled triangle could be the protected triangle, which is not here. So I'm going to draw one. I want you to draw the following triangle as well. Preferably not with your pair of compasses. I do know that some of you are probably doing that right now, even though I explicitly told you not to, but hey. In this triangle, let's use names, PQR. PQ is not the same as QR. It's also not the same as PR. All of these lines are different. So what's special about it? Well, it's basically very simple. It's this thing. Angle P is 90 degrees. And you'll see that right-angled triangles will be very helpful in the second video, because then we're going to use these triangles to calculate lengths, for example. Okay, so just as a quick review, what's special about these triangles? In an isosceles triangle, two lines, two angles are equal. Make sure that you write this down. In an equilateral triangle, all lines, sides, all lines and angles triangle, there is one angle of 90 degrees. Might be a chance to draw a triangle with two angles of 90 degrees, but you will probably not be able to do that. If you have any questions, just let me know.